we are going to use a linear approximation to estimate the value of e to the negative 0.015. Well, this right here cannot be done by hand because we don't know how to do e to the some number besides e to the 0, e to the 1, right? Things like that. But then the strategy is we are going to come up with a linear approximation, and that means we are going to use an equation of a tangent line. So let me just make a note, use equation of tangent line. And when we are talking about equation of a tangent line, you should give me the curve and the x value. Look at this number. This is e to some number. So you can choose the function to be e to the x. Let's come up with the equation of a tangent line to the curve. Y is equal to e to the x. And you should also tell me an x value. This number right here, negative 0.015, it's about equal to 0. It's really close to 0, right? So we can come up with the equation of a tangent line on the curve e to the x at the x value equal to 0. And let's get to work. We know how to do this, and that's pretty much the strategy. To get the equation of a tangent line, we have to get the slope. So let me do it right here. For the slope, we just look at the function, which is y equals to e to the x. I had to take the derivative of that, y prime, which is still e to the x. But then the slope is going to be a number. I have to plug in 0 into here. So let me just do this notation. I'm going to plug in x is equal to 0. So that will give me e to the 0, which is equal to 1. And this right here is a slope. Okay? And usually it's denoted by m. So I can write this as m equals to 1. And we got that first part. The second part, to get the equation of a line, I will have to get the point. And for the point, it's the usual x comma y. We know x is equal to 0, and y is equal to the curve, e to the x. And once again, I have to plug in 0 into here. Okay, so x is equal to 0, and this will give me e to the 0, which is equal to 1. But the purpose of this computation right here is to get x comma y, to get the point on the graph. And the point that we have is 0 comma 1, and 0 is going to be x1, and the 1 is going to be y1. And the reason I use this notation right here is because I'm going to use the point slope form of a line. I'm going to use y minus y1 equals to m times x minus x1. I have all the ingredients that I need. Let me just plug in all these numbers into the formula. Y is just y, minus y1 is this one, equals to m. M is this one. So I have 1 right here for this slope. X minus x1. x1 is equal to 0. So it's 0 right here. And we can do a few work right here. This is y minus 1 equals to 1 times x minus 0 is just x. Y minus 1 is equal to x. Let me add 1 on both sides. Plus 1 here, plus 1 here, cancel them out. So my equation of the tangent line is y equals to x plus 1. And this right here can also be written as L of x, because this right here is exactly a linear approximation. And we are talking about e to the something. Okay, so e to this number is like e to the x, around x is equal to 0. So I'm going to look at L of x is equal to x plus 1. And to get this right here, e to the negative 0.015, this number is about equal to L of, I just need to plug in this into x, L of negative 0.015. And I plug in negative 0.015 into x right here. I also have to do that right here. So I do it, plug in here, negative 0.015. I have to add the 1 at the end. And right here, you can do this by hand. You can use a calculator. Doesn't really matter. But then we know after you do negative 0.015 plus 1, you are going to get what? 0.985. And this number is pretty good. It's a pretty good approximation with e to the negative 0.015. And I should use approximation in between. Okay. And this is how you do it. That's it.